All right, let's talk a little bit about exponents and changing decimals to fractions. So lesson number 73. All right, so number one, you gotta memorize your doubles in multiplication. What do I mean by that? 4 times 4 equals 16. The reason why is when you're doing exponents, it's the same thing. 4 squared equals 16. Okay. Now, I have a clock in my room that is never right, but it has these exponents on it. So if you guys are buying this clock online, it's really cool, but it just never tells the right time. It's broken. So it is correct twice a day. So it has all of your exponents. So if it's actually square roots. So if it is square root of 144 o'clock, that means it's 12 o'clock. So there are some other problems that take your knowledge of this and make you apply it. So, for example, if you have square root of 144 plus 4 squared, well, we know that the square root of 144 is 12, so I'm going to write the answer below right there. And 4 squared is going to be 16. Now you can add those two together. Let's say that is going to be 28. Okay, so you're taking what you know about exponents and you're applying it to a problem. Let me look at your next one. Sometimes you're doing a factor tree for prime factorization. So let's say you have 1,000 and we want to make that into a factor tree. So I'm going to break that apart. That'll be 10 times 100. 1,000 divided by 10 is 100. And if I take 10 times 100, it'll be equal to 1,000. I can break 10 down into 5 and 5. No, don't do that. That's a common mistake. Some people are like, 5 plus 5 is 10. No, we're doing division and multiplication. Your brain needs to be thinking division and multiplication. 10 divided by 5 is not 5. 10 divided by 5 is 2. And these are both prime numbers because we can't break them down further. Now that 100 can also be broken down into 10 times 10. People say, Mr. Zone, you just said you can't do the same thing, same factor twice. I didn't say that. I said 5 times 5 does not equal 10. 10 plus 10, or 10 times 10, does equal 100. So this is correct, but I can break these down even further. So that'll be 5 and 2, 5 and 2. Circle them. They're all prime numbers. And now I can do 5 times 5 times 5. There's 3 5s. 5 times 5 times 5. And there's also 1, 2, 3 2s. 2 times 2 times 2. Now all of this can be condensed into what I call exponent form. Okay? So that is 5 squared. No, it's not 5 squared because there's 1, 2, 3 5s. So that'll be 5 to the third power times 2. Well, there's 3 2s, so that's also to the third power. All right, here's another problem. Some people might say, oh, I'm supposed to evaluate this. Oh, they're equal. That is incorrect. Real quick, I want you to pause your computer and then come back and see if you got it right. All right, we're back. 5 squared is the same as 5 times 5, which is equal to 25. Now, I know this isn't equal here. 2 to the 5th is the same as 2 times 2. Wait, this is a 5 here. That means I'm going to have 5 2s. Times 2, times 2, times 2. Now, let's multiply this out. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is going to be 32. And as you can see, 25 is less than 32. And the way I remember the less than and equal sign is the less than sign looks like an L. So your answer is 5 squared is less than 2 to the 5th. All right, the other thing that I want to go over, number 6, is you're supposed to take something like a decimal number and write it as a fraction. Now, we're going from decimals to fractions. So I would say in class, we play this little game in my class. If I ever say point, someone can correct me and they get, just a second, they get a marble, okay? And if we fill up our jar with marbles, which are back there, then we get like a brownie party. I call them brownie points, okay? All right, so I would say something like 0.5, and they say, Mr. Mizzou, you said point. That's not really how they sound, but they do have a point. And the point is, the correct way to say this is 5, because there's a 5 there, and then what place is the 5 in? It's in the tenths, THS, slobber, tenths place, okay? So that you would say 5 tenths, and that is written as 5 over 10. So this number, this fraction, the way you say it would be 5 tenths. And the way you say this decimal number has exactly the same name, 5 tenths, okay? So if you know how to say these verbally out loud, then you'll be able to convert back and forth very easily. So this is 5 tenths, this is 5 tenths. And the only thing you have to do is reduce to 1/2. So you try one. Let's try 6 tenths. Pause. All right, we're back. I hope you paused it and tried it on your own. This, of course, is 6 tenths. And then you have to reduce it. Half of both of those is 3/5. All right, let's move on to our next problem, which is if you have a mixed number that is a decimal. What do I mean by that? Well, let's say you have 3.75. Mr. Mizzou, you said point. Good job. I'm proud of you. Here's a marble. I dropped it on the floor. Oh well. All right. So 3.75. You would say, Miss Mizzou, you're supposed to say 3 75 hundredths. And if you can say that out loud, then you can write the fraction that goes with the decimal number. So I'm going to divide top and bottom by 25. That's our greatest common factor of 75 and 100. So the answer would be 3, and 75 divided by 25 is 3. 100 divided by, how many 25s are in 100? Oh, it's like saying how many quarters are in $1? 4. Okay? Now a lot of people do this. I'm erasing this. They'll say the answer, 3 and 75 hundredths equals 3/4. Don't forget the whole number. There we go. So the answer is 3 3/4. Now let's have you guys try one, number 9. Number 12 from your homework is 7 divided by 0.4. 4 tenths, Mr. Mizzou. Yes, I know. Here's a marble. It's on the ground over there. All right, so I'm going to take this. I'm going to change this to a fraction. 4 tenths. There we go. And I bring down the division sign. I bring down the 7. Oh, keep change flip. Keep the change, you filthy animal. Just kidding. First, before you do that, you got to change this to a fraction. What do we say? Put it over 1. Put it over 1. Put it over 1. Okay, if you insist, so demanding. Keep this 7 over 1. Change this to multiplication and flip this over, which is multiplied by the reciprocal. So I multiply straight across. 7 times 10 is 70. 1 times 4 is 4. Now I'm going to do top divided by bottom. 70 divided by 4. 4 will go into 7. 1 times 4 is 4. Subtract. 3 is less than 4. Bring down to 0. 4 will go into 30. 7 times 4 is 28. Subtract. 2 left over. 17 2/4. 2 goes on top, 4 goes on bottom, which is the same as 17 1/2. Hey, we got it. Awesome job, guys.